Myself, Dr. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study the resolution of a force. And what is the resolution of a force? Resolution of a force, it means when the force, resultant force, is making an angle with angle theta with the axis x. We are going to resolve or making this result R component into two components. One is parallel to axis x, another one is parallel to axis y, or horizontal component and vertical component. The horizontal component x equal to r cos theta and ry equal to r sin theta. So components here, finding the components of a given force in two directions, direction x and direction y. Then this phenomenon is known as, this process is known as resolution of a force. Now here, how we find out this cos theta and this is sin theta? Suppose we consider the right angle triangle. If we consider the right angle triangle, this is the r component, this is the x-axis, rx. Now theta, cos theta equal to adjacent side by diagonal side, rx by r. From this, rx equal to r cos theta. Similarly, if you apply sin theta equal to, this is ry term, this is ry by opposite side by diagonal, that is r. Now ry equal to r times sin theta. So in this manner, the component of r along axis x-axis equal to r cos theta, and the components of r along axis y-axis equal to r sin theta. So the resolution of a force is the process of finding the horizontal and vertical components of a force, that is a resultant R, is known as the resolution of a force. Now, if you want to find out, here we are going to find out the resolution of a number of coplanar forces. Here the coplanar forces means the forces acting in one plane are known as the coplanar forces. The forces are acting in one plane. Here the forces are R1, R2 and R3 are acting in one plane. Then this planar is known as the coplanar forces. How to resolve each force, resolution of a force? So each force we are going to make it into horizontal and vertical components. Now theta 1, where R1, R2, R3 are the forces which are acting at a particle O, and R1 is making an angle with the axis x is theta 1, R2 with the axis x is theta 2, R3 with the axis x is theta 3. R1, R2, R3 are making an angle made by R1 is theta 1 and theta 2 and theta 3. Alright. So how to resolve it? So here there are various methods are there. One of the method, the horizontal component, where we consider one more terms are there, H and V. H is the resultant component of all forces along x-axis. And V means resultant component of all forces in y-axis, axis y. Now here, H, resultant component of all forces on x-axis. Axis x means R1 cos theta 1, R2 cos theta 2, R3 cos theta 3. That's what the sum of resultant components along x-axis, that equal to sum of components of all forces along x-axis. The sum of components of all forces H equal to R1 cos theta 1, H equal to R1 cos theta 1 plus R2 cos theta 2 plus R3 cos theta 3. This is the sum of all horizontal component of forces. What is V equal to? Resultant component of all forces. What is the resultant component? This is the sum of all vertical component of forces. That is R1 sin theta 1 plus R2 sin theta 2 plus R3 sin theta 3. Now here the point is that resultant means equation. This is algebraic sum. So it can be the direction. Here we consider all are in positive x-axis. In this direction is the negative. The positive y is upwards, negative y is downwards. Suppose here the case study is like this. This is R1. I am considering another case study. This is theta 1. And here this is R2. I am considering, please carefully here observe, this R2 making with angles in this direction theta 2. And R3 is making individually with x-axis, horizontal axis. This is theta 3. Then how to resolve these components, horizontal and vertical? The simple method we are going to follow here it is, in this case, suppose case 1 and it is case 2. Please understand the difference between this case 1 and case 2. In case 1, theta 1 is making theta 1, theta 2, theta 3. All are the angles of made by the resultant forces R1, R2 and R3. Forces by R1, R2, R3. With the same, all are in the same direction with the same x-axis, y-axis. It is making with y-axis. R1 with y-axis theta 1, R2 with y-axis theta 2, R3 with y-axis theta 3. But in the case of case 2, theta 1 is making with OX positive direction, whereas theta 2 in negative direction, it is theta 2 with x-axis not starting from OX. And theta 3, it is coming from OX dash. R2 is making with angle that is OX dash and R3 again OX dash, that is theta 3. It is not like case 1, it is starting from OX, all R1, R2, R3 are. For the case 2, how to resolve the components? Now make it resolution of the components. Draw one parallel lines, both x-axis, axis x and axis y. If this R1 in this direction, draw vertically, it is upward direction. That's why OX dash. We have drawn a parallel line, okay, vertical line upwards. If you make it angle, wherever I am making angle with that, this the direction moves here towards OX direction. Now the term this becomes R1 cos theta 1. This term becomes R1 sin theta 1. Coming to the force R2. Coming to the force, draw a parallel line to axis y and parallel line to axis x. Now you make it R2 is in this direction from my side. If you consider it R2 in this direction, make it horizontal. Then the OX dash direction, this is a horizontal component. Next, make it vertical, OY, this is upwards. Okay. Now whatever this component, here the making angle is theta 2. Theta 2. That means it is R2 cos theta 2. And whatever here, R2 sin theta 2. Now coming to another situation here, the point similarly, draw another one, that is theta 3. Draw horizontal line and vertical lines. What is the direction of the R3? This is the angle made with theta 3. So make it horizontal. This is the theta 3 is in downward direction. Make it horizontal. This is the direction moves. So here. Now make it vertical. It is not vertically upwards. It is downwards. So what about this horizontal component? This is R3 cos theta 3 and here it is R3 sin theta 3. Now what is the sign convention you have to follow? The sign convention is this is a positive x direction and negative x direction. If it moves towards left, negative x, and it is the towards the right direction, it is the positive. Upward, positive y, downwards, negative y component, negative components. For this case study, sigma h, that means algebraic sum of all horizontal component of forces. The algebraic sum means it can be a positive terms and negative terms can be. Now R1 horizontal component, that is R1 cos theta 1 is positive. R2 cos theta 2, is this positive or negative? It is negative. It is moving towards negative x-axis. Next, minus R3 cos theta 3. This is sigma h. Next, what about sigma v? Now upward direction is positive y, downwards is negative y. So R1 sin theta 1 is positive y, R1 sin theta 1. Next, what about R2 sin theta 2? It is also positive, R2 sin theta 2. Next, R3 sin theta 3 is downward direction, minus R3 sin theta 3. So in this manner, we have to resolve the components. That's why it is known as the resolution of a force. Resolution of a force. The resolution of a force we consider here, there are two case studies. Case 1, the angle is making from the x-axis yx. In the case 1, all R1, R2, R3 forces are made angles with ox. Whereas in the case of case 2, this R1 is made with theta 1, the positive x, and R2 is making theta 2 with ox dash, negative, and R3 is making with theta 3 with ox dash, negative x-axis. For that type of case studies, how to resolve the components. So this is the methodology of a resolution of a number of forces, number of coplanar forces. Now coming to case 1. Now coming to case 1, what we have divided here, this is R1 cos theta 1 and plus R2 cos theta 2 plus R3 cos theta 3. For next, algebraic sum of vertical component sigma v. The sigma v means R1 sin theta 1 plus R2 sin theta 2 plus R3 sin theta 3. That is sigma v. Now, based on the value, if it is positive or negative, based on the consideration, the resultant comes. Suppose here we are considering all our positive horizontal components. This is h value. And all our vertical positive forces is the v value. What is the resultant? By using the Parallelogram Law of Theorem, these two sides h and v represents, okay, both the magnitude and direction of the two sides of a parallelogram. The diagonal represents the resultant of two forces. Diagonal represents, that is R. So Pythagoras theorem, this v is parallel to this v. According to Pythagoras theorem, R square equal to h square plus v square. From this, R equal to under square root of h square plus v square, square v. Now, the angle making here, it is theta. The tan theta equal to, from this triangle, is the right angle triangle, tan theta equal to v by h. Theta equal to tan inverse of v by h. Tan theta equal to v by h. That means sum of vertical component of the forces value by the values of all sum of the all horizontal component of forces. Alright. In this manner, we have to find out the resultant force of coplanar forces by using the method of resolution of a coplanar forces. Alright. Now we are going to study various case studies by using here one more case study. We are going to do it how to resolve, then make it component of the forces. Now here there is the O x dash is the y and it is y dash. It is the positive y and it is the negative y, and it is a positive x and here it is negative x. Further case study, now very simple case study we are going to make it. Here R1 as usual making with theta 1 with yx. Next R2, the R2 is making, will make you R2 is making with angle with vertical OY positive, that is theta 2. The next case study here we are going to study 4 forces. R3 here, again R3 is making with vertical theta 3. Next, one more case, this R4 making with vertical, we'll consider here horizontal theta 4. How to resolve these components of the forces? By using how to find out the resultant force? By using the method of resolution of a coplanar force system. Let us begin. I am following with R1 parallel. Draw a parallel line and horizontal line. This line may be draw exactly horizontal line parallel to this line OX and parallel to OY. So the angle making here it is theta 1. The term here it becomes R1 cos theta 1 and here it becomes R1 sin theta 1. Next, if we consider the next forces, parallel lines, draw horizontal and parallel. The angle is making this R2 with this is theta 2. That means this component becomes R2 cos theta 2. Whatever here this becomes R2 sin theta 2. Don't become Ethiopic manner. The Ethiopic manner means here horizontal component cos theta 1, horizontal component cos theta 2 here R2. No. The base, the angle with which the R2 is making with what axis? It is vertical or horizontal. It depends upon that concept that resolution takes place. It's not like, okay. Now, coming to next theta 3, draw a horizontal parallel lines x and y. Here R3 is making theta 3 with vertical, that's a theta 3. Now this component becomes, you turn vertically with that angle, it becomes downwards. So this becomes R3 cos theta 3, horizontal, whatever vertical, R3 sin theta 3. The next, draw horizontal and vertical lines. Now theta 4 is making with horizontal component. Okay. Now it becomes R4 cos theta 4 horizontal. Next it becomes R4 sin theta 4. If we draw this diagram, resolution, that's it. Then directly substitution. Now what is sigma h? Algebraic sum of all horizontal component of forces. Sigma h equal to, what is sigma h equal to? Sigma h equal to horizontal component of the forces. This is R1 cos theta 1 term, R2 sin theta 2, R3 sin theta 3, R4 cos theta 4. So R1 cos theta 1 is positive because the positive x-axis, minus the sin theta 2 term. Here it is horizontal. Don't think sin term is always vertical, but from the concepts, R2 is making with vertical, the angle theta 2 is making with OY. That's why the OY become horizontal component and OX, that is OX, become vertical component for this R2 force. Now what is horizontal? Parallel to x-axis, R2 sin theta 2. It is the direction of R2 sin theta 2 is negative x-axis. So R2 sin theta 2. Next, what is the term 3? Negative of R3 sin theta 3. Positive R4. R4 cos theta 4. The next term, sigma V. Algebraic sum of vertical forces. Sigma V. Sigma V equal to R1 sin theta 1. Positive Y direction. Next, sigma V for R2. Vertical component. That is plus R2 cos theta 2. Next, R3. What is the vertical force? Negative of R3. The direction of R3 is R3 cos theta 3 is negative Y. That is R3 cos theta 3. Next, R4. What is R4? Negative of R4 sin theta 4. So, here it is sigma H and sigma V. Now, what about R? R equal to under square root of sigma H square plus sigma V square. What is theta equal to? The theta equal to, or tan theta equal to sigma V by sigma H. Thus, we have to find out the resultant of a coplanar forces by using the method of resolution of a force. Okay. Now next, consider how to apply the concepts of a resolution of your forces such a way that we can find out the resultant force. So here in this figure, the two forces are acting at a point O. Resultant, determine the resultant and magnitude. Resultant in magnitude and direction. We have to find out the magnitude and direction of a resultant force. Now, here I consider always, you can apply it. I consider the angle making with OX. The P is making with OX is 15 degree and OQ is making angle with OP is 30. But what about OX? Is 45 degrees. So, the very simple methodology we are following here, whatever the forces are acting on a particle, we will make it the reference to the OX, we'll consider it. Such a way that all terms become positive, all terms becomes negative. Very simple. Now, P equal to 50 newtons, Q equal to 100 newtons. What about sigma H? The sigma H equal to P cos 15 degree plus Q cos 45 degree. The Q is with OX you have to consider, alright. So then what is the P equal to? Substitute P and Q here. P equal to 15 newtons, 50 cos 15 degree. What is Q? 100. Q is 100, cos 45. So 50 cos 15 plus 100 cos 45, here it is mentioned is 119 newtons, 119 newtons. That is sigma H. What about sigma V? The sigma V equal to, come on, P sin 15 degree plus Q sin 45 degree. Because the direction here, the Q, P is a positive X, make it a vertical. Again, vertical down, vertical. P sin 45, P sin 15 is upward direction, so positive. Positive Y and positive X only. Similarly, Q, OQ is horizontal component from my side. This is the moving positive X from my side. From your side, this is negative. So, you consider it positive. So, positive X axis, That's why Q cos 45 is positive. And Q sin 45 is upwards, positive. So P sin 15 plus Q sin 45. What is the value of the P here? That is 50 newtons, 50 sin 15 degree plus whatever Q, 100 newtons, 100 sin 45 degree. The sum of the sigma V, that is sigma V equal to 83.64 newtons. What is sigma H? Sigma H equal to 190 newtons. Sigma V is 83.64 newtons. Then R equal to resultant, R equal to under square root of H square plus V square. Now both are positive terms. If you find out resultant here, this is sigma H and here it is sigma V value. Okay, the resultant side, what is the resultant? Diagonal. How it comes? This is R, is the resultant force. This sigma V, this line is parallel to sigma V, this is sigma V. The sigma H value equal to 190 newtons. Sigma V value is 83.64 newtons. What about R? The diagonal side, hypotenuse square equal to opposite side square plus adjacent side square. So then diagonal side equal to under square root of sigma H square plus sigma V square. What is sigma H? 119 whole square. What is sigma V? 83.64. Then resultant force is calculated as 145.46 newtons. Alright. Now whatever the direction of the resultant force, the direction of the resultant force is theta. Theta equal to tan inverse of sigma V by sigma H. Whatever substitute value of sigma V and sigma H, then the values obtained here it is 35.10 degree. 35.10. Okay. Now this is the model we covered here to find out the resultant. Now interpretation. The resultant force should always, the value of the resultant force here always greater than sigma H or sigma V, both greater than sigma H and sigma V. And one more thing, the value of the sigma H is larger in this case, that is 190 newtons, and the value of the sigma V is 83.64. So by observing the resultant force sigma H and sigma V, R is greater than sigma H is greater than sigma V. And one more thing, very important here, R always, the resultant force is always greater than sigma H and sigma V. Okay. Now, one more is that the direction of the resultant force is also greater. Now here, why here 30 degrees, 45 degrees not greater, it is in between. You understand here. The theta P is making how much? 15 degree. Q is making how much angle? 45. The direction of theta km, the resultant force, that is in between, in the middle of, okay, the value between, the direction of resultant force is between the values of Q at theta 1 and theta 2. Suppose 15 degrees theta 1, 45 degree if we consider theta 2. So the theta P and theta Q if we consider, theta P is less than theta R is less than theta Q. This theta R is the direction of the resultant force. Theta Q is the direction, theta Q, that is 45 direction of the force, that is Q which is acting. What about theta P? Is the direction of the force P. Okay, that is theta P. Next, we are going to solve the next problem. You can understand better. Now we have to find out the resultant force. There are various forces are acting here. 40 kilonewtons, 15 kilonewtons and 20 kilonewtons. the angle made by these forces with OX, positive x-axis, is 60 degrees, 120 and 240. Now, see here, this theta 40 kilonewtons is making the angle 60 degree with OX, and 15 kilonewtons is making with OX, that is 120 degree, and 20 kilonewtons is making 240 degree with OX. These are all are coming from horizontal x-axis, positive OX. So we can substitute directly what is sigma h, or h equal to our sum of components, algebraic sum of horizontal components. That is sigma h equal to R1, if we consider it is 40 kilonewtons R1, 15 kilonewtons is considered as R2, and R3 is 20 kilonewtons. Then R1 cos theta 1, 60 degrees equal to theta 1, it is theta 1, it is theta 2, and here it is theta 3. So R1 cos theta 1 plus R2 cos theta 2 plus R3 cos theta 3. Why here this case? We consider all angles with respect to positive x-axis OX. So that's why R1 cos theta 1 plus R2 cos theta 2 plus R3 cos theta 3. We know R1, R2, R3 values, and theta 1, theta 2 and theta 3. Substitute in the expression, then obtained value is 2.5 kilonewtons. Sigma h equal to 2.5 kilonewtons. And what about sigma v? Again, sigma v equal to R1 sin theta 1 plus, because all are considered with respect to OX. That's why if you turn vertically upward positive y, that's why all are positive values here. Then R1 sin theta 1 plus R2 sin theta 2 plus R3 sin theta 3. Be careful, the theta 1 and theta 2, the direction of the forces which are acting with what axis? Is this positive x? According to that, we have to resolve it. Alright. Now R1 sin theta 1 plus R2 sin theta 2 plus R3 sin theta 3. Now substitute the known values. We know R1, R2, R3, theta 1, theta 2, theta 3. Substitute in this expression, the obtained value is 30.31 kilonewtons. That is sigma v. Now, resultant force equal to sigma h square or h square under square root of square h square plus v square. Substitute h and v values. The obtained value is 30.41 kilonewtons. So here in this case, the resultant force is greater than sigma h and sigma v, or h and v values. But here in this case, the vertical force, sum of the vertical forces are more than the sum of horizontal forces. What about the resultant force? Tan theta. Tan theta equal to v by h. What is the v value here? 30.31. What is the h? 2.5 kilonewtons. Then value obtained theta equal to 85.28 degrees. Okay, 85.28 with what? Positive. Now, here, in this case, sigma h is positive, sigma v is positive. So, it is in which coordinate system? The first quadrant. That's why here it is sigma h is positive, sigma v is positive. So, the resultant making here in this direction, resultant force making is theta 1 with a horizontal OX, that is theta r. The theta r is obtained as 85.28, first quadrant, and here that is what is here making, what is the resultant force? R is making 30.41 kilonewtons. So, all these three forces, the effect of R1, R2, R3 can be replaced by a single force, that is the resultant force, with the value of 30.41 kilonewtons. You see here, it's so mystic. 40 kilonewtons is making angle here 60 degree, 15 kilonewtons making with 120 degree, 20 kilonewtons making with 240 degree. Alright. The sum of these forces, you see how much? 40 plus 15, 55 plus 20, 75 kilonewtons acting. Total sum force with different angles. Okay. But this 75 kilonewtons effect can be replaced by resultant force, that is 30.41 kilonewtons. with the angle of how much? 85.28 degrees. The same effect it comes. This methodology is described by the law that is known as the Parallelogram Law of Forces. Alright. So parallelogram law of forces to find out the resultant force. But this is the resultant force concept. The resultant force means the number of forces may act. The sum of the forces is larger. Okay, one person is pulling with 40 kilonewtons with 60 degree, and that person is pulling the same body with 15 kilonewtons with 120 degree, and another person is pulling 20 kilonewtons with 240 degrees. But all these forces, the sum effect can be replaced by a single force. That single force is known as the resultant force. Okay, with this session, we have to conclude that in this session we learned what is the resolution of a force, of a single force system, and resolution of a coplanar force system. And by using the method of resolution of a coplanar force system, we calculated the resultant force of a 2-force system and the 3-forces system. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.